Hello everyone. In this video I'm gonna showcase how I created this procedurally generated dungeon in Unity, and as you can see this is the dungeon that was created. It has doors and different types of rooms and different objects that are placed randomly inside the rooms. Okay, so if I in the game scene, let's walk around it. Okay, I'm just gonna sprint past most of the things here. I created this dungeon for my upcoming game, uh, which is a survival horror game in which you manage settlements and resources for how much that settlements consume. And on your journey, you encounter different monsters and creatures and different things. More about my game coming in a devlog, which will be up soon on my channel. Okay, so let me just give you an overview of what this method is. First of all, let's see some prerequisites about this method. This is a custom made method by me. This is not gonna be using any algorithms like A star or wave function collapse. This is a room based generation. So you make prefabs of rooms uh, and decorate them, or use different methods to decorate them, and then you just align those rooms dynamically and randomly. Okay, on the runtime. Okay, so the downs side for this algorithm is that there are basically no loops in the dungeon. What I mean by that is it's basically like branches. So we have a main entrance here. Just gonna name this entrance. It has 4 entrances, and it's gonna like branch out from here. So in using this method, you will have to come up with different ways to make loops in your uh, dungeon. For example, you can generate the dungeon before, and then you can make random loops with the A star algorithms, or you can make like hatch systems which teleport a player from one place to another inside the dungeon. So let me first show you how I have this set up with the prefabs. So this is my level. This is the prefabs I have for this level. Okay, so this is the base room, and all the dungeon parts that I have created here are basically prefab variants of this one prefab. So it is a base room, and it has a network object with this is a co-op game, so I have this network object. If you're not looking for a game that has co-op or multiplayer involved in it, you don't need that. I have this script dungeon part, and I'm just gonna open this up. Also, I'm gonna open the dungeon generator and entry point. Okay, so these 3 scripts are responsible for all of the generation of this dungeon. I'm not gonna be coding this out from scratch because that would take a very long time. I made this algorithm and like this method in a lot of days, so it takes a lot of time to just code this out. So I'm just gonna go over it and show you all the code and the methods I use to align these things and generate these things randomly. All right, so this is my structure here. I have this dungeon part script attached to this. Let's take a look at room 1 here. Okay, so this is room 1. I created the models for this in Blender. So it has, and this is the mesh for this. It's a simple box, and I have attached a mesh collider to this, and there's a box collider underneath this. This is so it prevents the player from falling below this. Okay, so then the main thing that is gonna be responsible for making this algorithm work is the entry point. So I have this empty game object which has two entry points because this room has two entries, uh, entries or exit you can call them. So this entry point one, I have this aligned. I have, you can see that I am in the local axis of this object, and you can see that it is aligned at the center of the doorway and it is facing outwards. So the z axis is facing outwards of the room, and same goes with this entry point 1. As you can see here, it's also at the very edge and it is facing outwards, the z axis. I have these entry points and there is an entry point script attached to them. Now let me show you the scripts for this. Okay, so I have this dungeon generator script which is attached to the, if I go to the test level scene here, which is attached to the dungeon generator game object. It is just an empty game object which is uh, very below, very low and on the y-axis, because I want the dungeon to be below my like safe area level. Okay, so it has a network object and a dungeon generator script which has all the rooms and hallways that I have in that I have prefabs for. Okay, so let's see how I'm generating this. So I'm creating a singleton for this. Then I am serializing entrance for this. This will be the first room that dungeon will branch out from. So this is the entrance which you saw on the first room. Then I have these list of game object which are the rooms, that these are all the rooms that are gonna be involved in the dungeon. These are special rooms. This is also a list of game objects. Special rooms are basically like a unique type of room which might have special loot, which might have unique interactions with some objects. So these have like a probability. How often do I want to spawn these? Next, I have alternate entrances. These are basically alternate entrances to the dungeon. So I have set up one main entrance for the dungeon, and a dungeon can have multiple alternate entrances. So if you have played Lethal Company, then this can be like fire exit for your dungeon. Okay, next thing I have is a list of game object which is hallways. So these are different types of hallways that I have in my game. These are also basically just like rooms. They are literally similar to rooms. They don't have any difference, but I keep them as a separate object, so I can like differentiate how many hallways and how many rooms I want in my dungeon. This is so I don't create a dungeon which only has rooms or hallways. It should be a mix of those. Then I have a prefab for the door object, which I place between the doorways, of course. Then I have a field for the number of rooms, how many rooms I want the algorithm to generate. Then I have a layer mask with, this is a special layer mask for the rooms. Here, as you can see, I have created a layer mask. You can create a layer mask by adding layer here, and you can create a special layer for this and just have that here. Next up, I have a list of private object which is not serialized. This is a list of generated rooms, and it has my type of like dungeon part. So these are all the rooms generated inside the dungeon, and then just a simple boolean value is generated. Then I am setting the singleton value here. I can also do that in the start. I don't know why I'm doing that here. I will just I'm not gonna bother with it right now. Okay, start function. I'm just creating a list here. Okay, I have this method here which I am triggering from an other interactable object which creates this dungeon. So I have this start generation server RPC. If you're not using multiplayer, then you don't need server RPCs and you don't need to know about them. So this is basically I'm calling a function here. You can say that. So you can think of it like I'm calling a generate function here. You can skip this function. So I have this generate functions. I first create the dungeon, then I create the alternate entrances, then I fill the empty entrances which don't lead to anywhere, and then I just set the is generated to true. So let's first see what the generate method is doing. So this is the generate method. It's quite long as you can see, but I will try my best to explain so it doesn't become overwhelming. So I am just creating a for loop here which has an index which is starting from index 0, and it's gonna be number of rooms minus the alternate entrances count. So if I'm creating like uh, 10 rooms and I have two alternate entrances, so at the end of the algorithm the algorithm should result into 10 rooms. So that is why I am generating a dungeon with mine or with the number of rooms minus the alternate entrances count. So the because the alternate entrances are also a room, so I don't want to uh, generate rooms more than the count that I have specified in the editor. So you can also like make a functionality for placing alternate entrances, like you can just place a random door at a random point in the uh, dungeon. With that can also work, but I didn't really go with that route here. I just thought of it right now. So okay, so on the first time, if the generated rooms dot count, so if there are no rooms generated, then I just want to generate the entrance. So this will be the starting point of the dungeon. This is where all of the dungeon is gonna branch out from, and then I'm just setting the transform dot position and the transform dot rotation for this entrance. This is so the dungeon starts out from uh, the point in the space where this game object is. So I have this dungeon generator method in the on -1000 y axis. This is so the like my other level is way up there, as you can see. I don't know if you can see this, but like there are some blocks there. That's my like safe area type place. So I want to generate a dungeon down here. That's why I give this a position and a rotation. So that's that. Then uh, generated rooms, I'm setting the parent to null. This is also a multiplayer thing. You don't need that if you are not working with the multiplayer. Then I have generated room. Then I'm just getting the dungeon part component, and then this is a multiplayer thing. I'm just spawning the game object for all the clients, that all the players that are connected to the game, and then I'm just adding this dungeon part which is from the entrance I created, and I'm adding that to the generated rooms list. Okay, so that's done. Let's just collapse this. Now is the main part, which is so long. So next thing is the logic is for placing the rooms is pretty similar all the time, but it's just the code is so long here because I'm considering different possibilities, like creating chances, like there's a 50% chance that it should place a hallway and a 50% chance that it should generate a room. And when it's generating a room, it also checks that there is a 10% chance that it generates a special room and 90% chance that it generates a normal room. So in the else, that is exactly what I'm doing. I create a boolean variable here, should place hallway. It just creates a random variable of float value from 0 to 1, and it checks if the value generated is above 0.5, so it's a 50% chance sort of thing. So if that is true, then it should place a hallway. If it is not true, then it should place a room. Then I have this variable dungeon part, which is a random generated room that is already generated inside the dungeon. Then I have a transform point, which will be the entry point of the previously generated room. So I have room A here. Uh, so I have room A here, and then I have room B. Then I need an entry point for A1, and I need an entry point for room B. So I can attach these two rooms together from these two entry points. So this room 1 entry point is basically A1, the entry point for the first room. And then I have total retries and retry index. This is a safety feature, which I will tell you why I'm doing this in a little bit, which is exactly now. So I have this while loop here, which keeps on running until the random generated room variable, which is this, is null and the retry index is less than total retries. So this is a safety feature that I have in place, so it only runs 100 times. So sometimes when you're working with while loop and you're giving it like some random related conditions, so it can like there can be situations where it like never finds a room, but and it continuously keeps running the loop in an infinitely. So to prevent infinite loop, I am putting this total retries here, so this loop never runs infinitely. Inside the while loop, I have a random number which is from 0 to the generated rooms count, and then I have a room to test, which is a randomly selected room from the list. And then I check if that room to test has available endpoint, and if that is true, then I get this room 1 entry point variable. So this will automatically assign the value for this variable, and I will show you how I created this has available entry point method in a bit. But okay, so then I just random generated room, I just set this to this one, and I break the while loop, and after that I am just increasing the retry index. Okay, so before I proceed any further, I will first just show you what the dungeon part and the entry point scripts are doing here, because they are not there is not too much complexity there, and let's just get that out of the way. So this is the dungeon part variable script, sorry. This one is irrelevant, I'm not using this anywhere right now. So I have a layer mask for the room which I showed earlier. This is an irrelevant. Then I have a variable for filler wall. So filler wall is basically if all of the dungeon is created, then there are empty entry points which were not used in the dungeon. So I fill those up with the filler wall, which is which is just a cube which has the same material as my walls have in the dungeon. So next I have a list of entry points. List of entry points. These are the entry points that are, for example, these are the entry points. So I'm gonna just keep this script up, keep this thing open. Okay. Next I have a collider here for the. This will help us identifying if our generated room is overlapping with another room in the dungeon. If that is the case, then we don't want to like place that room there because it is overlapping the dungeon that is already generated. Okay, so let me just first show you the collider. So this is just a simple box collider that is around the cube, around the dungeon. Okay, okay, so this is the box collider here. As you can see here, it is a trigger box collider, and it just covers up the whole box. And one thing that you will have to take care of is that this box collider should never be complete, should never like cover the entrances completely. So I have this I have this entrance here, entry point here, and you can see here it is outside the collider. If I slow down, whoa. As you can see here, it is outside the box collider. That is because if this entry point is used and there is a room that is placed at the location of this entry point, then if the box collider is covering the whole uh, whole mesh, then it might overlap with the room that was placed here. So this is why I have this a little bit behind, a little bit smaller than the actual body of actual complete box of the room. And because there are walls here in the room, and the walls can basically hide some smaller overlapping. That's why I have the entry point a little bit outside the box collider. So this is very important here. Okay, so what is the entry point here? The entry point is basically uh, a script which has one boolean variable is occupied, and I have a function here set occupied, and it takes the value which is by default true, and it just sets the is occupied variable to that value, and there's a public function here which returns the value of is occupied. Okay, now let's take a look at this has available entry point function here, which is inside the dungeon part. I closed the entry point function because there is not much going on there. So in this has available entry point function, it basically checks through the list of game entry points and returns an entry point which is not occupied by the dungeon. So it has an output variable here in the parameter, which is an entry point which will be found here, and it returns a boolean result. So I have this resulting entry variable here and a result variable here, and I am also using while loop here to find the entry point. So I also have this safety feature for total tries and such. So entry point dot count is if there is only one entry point, I just want to like take that entry point because there's no need to run a loop here, and I'm gonna get the entry point script from this entry point and if that entry point is occupied, then I want to return the result to set the result variable to false and resulting entry to null. And because if there is only one entry point and it's already occupied, then I can't really use this room or hallway to at any place in the dungeon. So if it is not occupied, then I set the result to true and I set the resulting entry to entry, and I set it to be occupied. Then next I just set the entry point to resulting entry and I return the result. Next, this is the case if there are multiple entrances and exits to the room. So while resulting entry is equal to null and retry index is, this is just a safety feature, I select a random entry point from the entry points and I try to get the entry point component from there, and I just check if it is not occupied. Then I simply just set the resulting entry to entry, then result to true, set it to be occupied, and I break the loop. I'm just increasing the index here. Then I set the entry point to resulting entry and I return the result. That's pretty much how this function works. So a little recap for this: it checks if there is only one entry point, then it takes that one entry point and it checks if it is occupied or not. If it is not occupied, then it returns this that entry point and ends the function. If and then um, for multiple entry points, it runs a loop over it runs a loop and finds a random entry point from the list of entry points and check if it is not occupied. Then if it is not occupied, then it just returns that entry point. Okay, next up I have this unused entry point function which receives a transform of entry point and it gets the component of entry point and it sets the occupied to false. This is used in the case when, if for example, if the room is placed at some place in the dungeon and it overlaps with the already produced dungeon, or it overlaps with another room, then I don't want to use it at that place, so I set the entry point to be unoccupied and then I move it to another place and set it occupied again. Okay, the next function here is fill empty doors. This is done at the end of the generation process. So when all of the dungeon is generated, I just take all of the entry points and I find out if they are not occupied. If they are not occupied, I just spawn a filler wall there to so the player cannot go through it. All right, then I'm just drawing the collider here on the gizmos, and then this is just written multiplayer related stuff. All right, so back to the generation process. We were here. We found out if the previously generated room has an available entry point, and if yes, then we proceed forward. If then I'm just spawning a door here and it is spawned at the location of the dungeon generator game object, and then I use this variable here should place hallway. Okay, I'm gonna collapse this. Should place hallway. This is the variable I created up here. This is a random 50% chance that to place a room or a hallway. Then inside this function, inside this if statement, I create a random index from the hallways count, and then I instantiate that random count random hallway, then setting its transposition and rotation. Then I also set its parent to null. This is also a network thing. You don't need to do that if you're just doing single player stuff. Then I get the dungeon part component component from this hallway, and I spawn this object for all the clients. And if dungeon part has available entry point, if the hallway I created has an entry point, which it obviously has because I just created it, it's not aligned to any room, then I get the room 2 entry point here. So this gives us all the things we need to the room A, room B, room A entry point, and room 2 entry point. So this gives us all the things that we need. Then I just add this uh, generated hallway dungeon part component to the generated rooms list, and I align the door to the room 1 entry point position and rotation. This is so the door appears in the direction of the room it is gonna be opened in. And then I run this function align rooms. Okay, so let's just first go to the align room function, and let me first show you what I'm passing for this. It is the first room that I find out from this while loop, and it's transform, and then the generated hallway which I just created here, and the room 1 entry point and room 2 entry point. So A, B, A1, B1. Okay, now let's go to this function here. I alt clicked on this. So it takes a room 1, room 2, room 1 entry point, room 2 entry point. So currently how I have I have it set up. I'm not really using the room 1 here. You can also remove that if you're just gonna copy this. So first of all, I find the angle between the room 1 entry point and room 2 entry point. So vector 3 angle and room 1 entry point dot forward and room 2 entry point dot forward. This is why the z axis I should have been facing outwards from the room. Okay, so I'm gonna set the transform point for the room 2. So setting the transform point is like this. So let me show you. I have this object here, A, and then where did it go? Okay, I'm gonna copy this. I have this object B. So setting the transform point is like this. So normally if you rotate an object, it's gonna rotate it around its axis. Okay, so but if you set the transform point of A to B, like I am doing here, I'm setting the transform point for room 2 to be room 2 entry point. So I want to rotate the room 2 around the room 2 entry point. So this will rotate the room A around B. So if imagine like B is rotating here, so room A will rotate with room B. So that's pretty much what this does. Okay, so next I'm setting the transform point here. Next I'm gonna set the Euler angles to be, this is gonna be room 2 Euler angles X and y-axis, z-axis, and I'm just gonna rotate the room in the y-axis by adding the angle that I calculated from these forward x entry points. So this is gonna rotate our room to be facing towards each other depending on their entry points. So the next thing I'm gonna calculate is the offset for the rooms. This is gonna take the value from room 1 entry point position and room 2 entry point position. This calculates an offset, like it calculates the how much far apart the room 1 entry point and room 2 entry point is. So now that at this point in the code execution, the two rooms are basically facing each other, and then I calculate the how far apart they are from each other by their entry points, and then I just move the room to that direction. that distance, like how that what is the distance between the two entry points, and then I just move the room to that distance. And then this is a function by Unity engine physics.sync transform. This function is this was very tricky to deal with and find for me. So basically what this function does is when you are moving around objects that have colliders and teleporting them basically in the engine, so sometimes the transform of the objects is not synced properly. So if an object is so I'm creating all the objects at this game object's location. So they are all generated at location O. So I created a room and main entrance here at location O. Then I create an the second object, which was room 2 for example, then it is also created at location O. They are always on top of each other. When I'm checking for like overlap, if they are even if the object is moved, the Unity engine will still say that it is overlapping, because the colliders don't move when you're properly when you are like teleporting game objects. And that is why I tell the engine myself that you should update the colliders now. So this is the alignment function, and we have aligned the rooms here. Next up I have is handle intersection part. So handle intersection takes a dungeon part component. This is the hallway, for example, I just instantiated here. This function also returns a boolean value. So if it returns true, then that means that this dungeon part, the hallway that I just generated, it is overlapping with a room or hallway that was previously generated in the dungeon. So this should not be placed at this location. If that is the case, then I just unuse the entry point for this entry point room 2. So this is B, and I just want to unuse B2, B1, and this is A, and I want to unuse A1, entry point 1 for the room 1. Then I try to retry placement here. The retry placement algorithm takes a generated hallway, which I just generated, and the door to align. So the door that was placed for the door that was like instantiated here, so I don't instantiate another door. I just take it and yeet it at another place. Then I just continue the algorithm. Okay, so now let's check the handle intersection part. Then I will get to the retry placement part. Retry placement is pretty similar. Okay, for the handle intersection, I have a boolean here, which will be the result of this algorithm, and I initially set it to false. Then I do a physics overlap box. This overlap box function creates basically a box, and it returns all the colliders that happen to be inside this inside that box. So I'm gonna give it a value of that dungeon part collider bounds.center. This is the collider that we have here in the dungeon part. So I this is it takes its center, its size divided by 2. The overlap box itself does some things with like taking half the size of the box, and it automatically doubles it internally. I don't know why but it's the way it is. And then I give it a rotation of a quaternion dot identity, and then a room layer mask. Then I just go over all the hits that occurred within that box, and if that hit is this game object itself, if it hit itself, then I just continue that. I don't care about that. But if the hit is not itself, but it hit another collider, then I set the did intersect to true. I break the loop. It is intersecting. It is wrong. It is in the wrong place. Then I return the did intersect. So that's it. Okay. Next up, uh, let's retry placement. Retry placement takes an item to place. This is a room or hallway that is generated, and a door to place. So it is pretty similar logic, except the only difference the only difference there is that it uses recursion. So I create a random generated room one entry point, safety feature for the total and retries and retry index, and this is the like the loop that runs in similar fashion. It takes a random number, random generated room, checks it if it has an available entry point, continues, is safe to like run 100 times. Then I get the dungeon part from the item to place. Then I uh, check if this object has an available entry point. Then I get the room 2 entry point. I place the door at the room 1 entry point. I try to align them again, and I check for an intersection again, that if like it is placed at another location, and if that place also is like not correct and it's intersecting with other dungeon parts, then I unuse the entry points and I retry placement again. So this function keeps on running until uh, it places it at a correct spot. Okay. Whew. So next up, this logic is pretty similar. So how we place the hallways is how I place the rooms, the special rooms, and the alternate entrances and everything else. So I get a generated room here, value variable here. Um, so I check here if the special rooms count is, so these are the special rooms that I have assigned in the editor. If there are special rooms that can be placed in the dungeon, then I create a like 10% chance if by a 0 and 1f variable that should I place a special room. Then if yes, then it selects a random special room, then it spawns it. If not, then it spawns a random room just from the normal peasant rooms list, I guess. If there are no special rooms, then it just spawns a normal room. Setting parent to null, try and get component for the dungeon part, spawning it for all the clients, check if it has available entry point, because it has available entry point at all cases because I just created it. Then I add this to the dungeon part, align the door, align the rooms, handle intersection, and same thing, yada yada. All right, that's pretty much it. The generate alternate entrances, you get the idea. They are like the same thing as how I am generating the previous things. Then after all these generation is done, I just fill the empty entrances and I loop these generated rooms list and I just fill empty doors. Yeah, that's pretty much how this dungeon is being generated. I talked a lot, my mouth hurts a little. Okay, then let me just show you what it generates. I'm setting a scene flow currently in the game, so this won't work. I have to go from the main menu. And now let's, okay, let's go. Uh, by that, but pressing the button, I spawned the dungeon, and now I can like go there. So these are the rooms placed. This room is closed off by that. As you can see here, this room is also closed. So it automatically, this stairs lead downwards. So as you can like see here, it automatically attaches the rooms, and this one has a filler wall. So this is the end of a roots. For example, this is the edge of the root for this dungeon. Now let's yeah, I think you get the idea. This is the dungeon that is generated here. As you can see here, these stairs go upwards into this section, and it has some way here. So you can like, you get the idea here what it's generating. Something that I will warn you about is that this algorithm requires variety of doors. So you should have multiple hallways and multiple rooms in order for this to like actually uh, work well. As you can see, there is no overlapping here. It's perfectly aligning every room and stuff here, and like placing the filler walls and other things. This is part of my co-op horror game that I'm currently working on. And if you like this video, make sure to subscribe to the channel. And if you want to support me and support my work, I make a lot of tutorials on this channel. I'm currently new on at this thing. I also have a devlog coming for my game soon on this channel. So if you want to watch that, make sure to subscribe to the channel. If you want to support me further, you can help me out by subscribing to my Patreon, linked in the description. You can also join the Discord, that is also mentioned in the description. Thank you for watching if you made it this far, and I'll see you in another video. Goodbye.